There we go.
So we are live. Good morning, everyone. I'm really happy to have Dr. Payal Bal here with us from the University of Melbourne. Uh, she will give a talk on. Oops, sorry. So she's a postdoctoral research at the University of Melbourne, working on developing an integrated approach for biodiversity assessments using economic, land use, and biodiversity models with collaborators at the University of Melbourne and Deakin. So she previously worked with principles of decision theory and optimal monitoring to help improve the use and selection of biodiversity indicators for conservation. So we are really happy to have her here with us today to give this talk at our international seminars at the Ecology Graduate Program from URGS. And she will give her presentation that is called Developing the Capability to Predict Future Biodiversity and Land Use Conflicts. So thank you again, Payal, for accepting our invitation and being here with us.
Thank you, Fernanda.
So I
So,
will remove myself and put your presentation, and I will be here on
so
the
I'm good to
backstage.
go?
Good
Okay.
to go if you need me.
Okay.
I'm
All right.
here.
Thank you. Um, so, good morning, everyone. Good evening from my side of the world. I'm joining you today from Melbourne in Australia, the city that has become notorious for being the most locked down city in the world. But in an hour from now, we finally come out of lockdown after a really long time. So I apologize if, in my excitement, I rushed through the presentation a bit too quickly. But thank you for the invitation to present to your group, to Larissa for extending this invitation, and Fernanda for coordinating it all. And also, please accept my sincerest apologies for not being able to make this last week. I'm really grateful for this opportunity to talk to you all again. Before I dive in, I would like to acknowledge that I am speaking from the traditional lands that belong to the rightful traditional owners, the Wurundjeri people of the Kulin Nations. I have deep respect for the elders of these and other communities across Australia, and I acknowledge that sovereignty on these lands was never ceded. So, I would like to begin by telling you a little bit about myself, especially because we've never met, and also more so because, given the lack of face to face contact during lockdown times and the absence of exchanges that you would normally have over cups of coffee or lunches with university visits, this is the best we can get. So, I'm from a town in North India called Chandigarh, a place that's known for its architecture. In fact, it's famous for its architecture and its art. And this is my lovely family. My mum was an academic, and my dad, an avid collector of films and magazines. And I think I owe my interest in research to the two of them, especially to my dad's enormous collection of National Geographic magazines. I am one of four sisters, four wonderful sisters. This is my granddad and my grandmother, who turned 92 last week. So I did my schooling in Chandigarh, and then I went to Delhi University, where I did a bachelor's in zoology. From there, I moved to Bombay for a couple of years to intern at a local conservation NGO called the Bombay Natural History Society. This is where I got my first experience of working in conservation advocacy. After that, I went to Pondicherry to pursue a master's in environmental science. And here I worked with the French Institute of Pondicherry, which gave me my first fieldwork experience. And here I worked with the French Institute of Pondicherry. I worked in the south of India in coffee estates, looking at the human elephant conflict problem. So, a really pervasive problem that resulted in loss of property as well as loss of lives on both for humans as well as elephants. Um, I then pursued a master's in St. Andrews in Scotland, a course that trained me in quantitative ecology and modeling. From there, I came back to India to do a short stint in a city called Bangalore. And if any of you enjoy Indian food, that is a must visit city that you must visit when we can travel again. So I worked at the Indian Institute of Science doing quantitative analyses of vegetation patterns to look at indicators of change or indicators of ecosystem collapse. And finally, in 2012, I got a scholarship to do a PhD at the University of Queensland with Dr. Jonathan Rhodes, who is an exceptional supervisor and a researcher. Here, I worked on methods for evaluating monitoring strategies for conservation decision making. So, focused on methods that were based in principles of economics, like cost effectiveness or value of information. And the idea, the aim of that PhD was to have these methods to test or select indicate biodiversity indicators. And then finally, in 2017, I landed up at the University of Melbourne, where I'm currently based with the Quantitative and Applied Ecology group. So this is an incredibly diverse and smart group of people that I'm lucky to be a part of. And so now on to the stuff that I'm working on these days. The work that I've been involved in for the past 3 years at the University of Melbourne as a postdoc is about developing the capability to predict at national as well as global scale what will happen to biodiversity, either under different policy choices or more broadly in the future. And by future, we mean we encompass a whole suite of environmental and socioeconomic scenarios. So that means that we are looking at impacts of climate and land use change, but recognizing that climate and land use are themselves driven by broader processes like population growth, trade, demand for resources, consumption preferences and patterns, etc. So the question in this process, in this project, really comes down to how. How do we actually do this? Look at all of these broad processes or global phenomena of consumption, trade, climate, land use, change that are driving local level impacts on biodiversity. And often these processes are interacting, which makes things more complex. So who are we? This is the research that I'm presenting has been the brainchild and toil of many, based at the University of Melbourne and other universities in Australia, as well as colleagues in the UK and Europe. We include PIs, so Brendan Wintle, who I work directly with, Brett Bryan, who's a land use modeler, Brendan Wintle, Brendan's expertise is in biodiversity modeling, Brett Bryan, who's a land use modeler, and Tom Compass, who's an economic modeler. We have a number of PhD students, Simon Kapitsa, Natasha, Marco, who are all covering, Matthew, who are all covering different aspects, have covered or are covering different aspects of the project. A number of postdocs that are currently with the project, Skip, Casey, Pia, myself, as well as advisors on technical aspects of the project, such as on things like data servers, high performance computing, code optimization, because as you will see during this talk, that this project, in addition to the conceptual questions that we're trying to address, has a number of significant data and computation requirements. And so figuring out the solutions to the technical aspects of the project has also been the bulk of the work over the last 3 years. And I should say the technical advisors were Usha, Jonathan here, and Chris Ware. Right. So, okay, so understanding the impacts of the global interacting processes, or what we call in the literature as telecoupled processes on biodiversity, means that we have to start by looking at the big picture. So let's start by thinking about consumption. Thinking about the groceries we buy, coffee we prefer, how much meat we consume, and where these things come from, we can see how individual choices can drive the dynamics of the local economy, but also how our consumption can drive systems of production and environmental impacts on the other side of the planet. So palm oil, quinoa, coffee, meat are just some of the common examples that make this telecoupling obvious. But of course, it's not just the individual choices at the individual level that may be impacting biodiversity. Trade can facilitate consumption and production patterns at much larger scale, so driving potentially much larger impacts on the environment and the biodiversity therein. Um, International trade has seen a steady increase over the past 20 years, and this trend is expected to continue to grow, especially with the emergence of the free trade agreements. Now, these FTAs, free trade agreements, basically reduce or remove trade barriers. So, by minimizing regulations or lowering taxes, and as such, they transform the way resources are produced, exchanged, and consumed across the world. Now, these decisions, the FTAs, drive therefore new areas of expansion across different sectors of the economy, across different countries, which can translate to large changes in global land use, along with potentially large environmental impacts. So we have also seen historically that as countries move through stages of economic, social, and demographic change, the way they use land use, the way they use land changes too. So global land cover has changed drastically with large increases in agricultural land. And these trends are being modeled into the future by teams across the world, most of which say that the trajectories that we have seen thus far will continue under business as usual type scenarios versus other alternative scenarios that that perhaps emphasize or focus on sustainability and observing environmental boundaries. This here is just indicating the projections from different models. Now add to this mix the old and trusted villain, the Lex Luthor of the saga, climate change. We know now with more certainty than ever before, given the new sixth IPCC report, that the climate is changing, that it is expected to continue to do so, and that this change is without a doubt attributable to human activities like agriculture, agricultural expansion, energy use, population growth, resource extraction, and so on. And all these activities drive land use change and in turn have severe consequences for natural systems and the biodiversity therein. In fact, there is growing recognition amongst policymakers, as is evident from this press release of the IPBES, that we really cannot understand the changes in biodiversity or climate if we don't look more closely at the human, social, and economic processes and choices that are driving these changes. Now, this link between consumption, production, trade, and biodiversity is being increasingly recognized in the research. So, for example, some studies like Lenzins or by Moran have looked at where impacts on a species in a specific country might be originating from and what the degree of that impact might be. But even so, most studies will only go so far to say that a risk is present and where the risk is emerging. But we cannot yet quantify how much of a species habitat might be lost and where as a result of increased consumption or production of a commodity. Studies have also started to explore more sophisticated methods of integrating different models to capture some of these coupled economic, ecological processes. They are becoming bigger in their scope. So, for example, the IPBES report, which is now driving research in global biodiversity assessments, they're also becoming bigger in the models that they use, the amount of data that they use, as well as the number of authors that are listed on these studies. But this is the context where the current project sits as well. So in this project, we aim to build an integrated assessment framework, so a coupled ecological-economic assessment framework, to capture these ideas of telecoupled drivers and their impacts on biodiversity. because we want to be able to address fundamental questions about the combined impacts of consumption, climate change, and land use change on biodiversity. Now, if you've heard the term IAMs, which I'm sure most of you would have, we know that most IAMs tend to be highly complex and not reproducible except by the people who develop them. But we want, through the work that we are doing now, to be able to provide a much simplified, transparent, and reproducible framework, which we can adapt to a number of different kinds of applications. But most importantly, an assessment framework that can help us tease apart things like what is the feasibility, the risks and benefits, and the cost of different policies or incentives to reduce biodiversity loss. So, how do we build this IAM to downscale global patterns to the local land use and its impacts on species distributions? We do this by bringing together expertise in economic, land use, and biodiversity models. So we use an economic model which gives us change in commodity demand. So, for example, for wheat, rice, coal in the future under different scenarios or under different policies, the commodity demands are linked to specific land use classes. So, such that we assume that the amount of demand, the quantity of demand for a commodity is linked to the surface area of land that is required to produce that commodity. So, this is how the outputs of the economic model feed into the land use model, and the predicted land use from the land use model is used as a variable in our biodiversity models. And here we're um, primarily using species distribution models. Now, a number of studies look at these links. Some look at the economic land use link, others at the land use biodiversity link. But a fully integrated approach that goes from economics to land use to biodiversity at the global scale, as well as with sufficient detail to look at the impacts for individual species, is still lacking. So let's talk about the different components of the framework. So firstly, we capture the scenarios through the use of existing RCPs and SSPs. So RCPs are representative concentration pathways, which are climate-related scenarios, and they are represented as greenhouse gas concentrations that lead to specific changes in temperature in the future. And the SSPs, which is the shared socio-economic pathways, they complement or correspond the RSPs. So these are basically narratives or storylines that describe alternative futures for the world based on assumptions around economy and lifestyle, policies, technology, education, and the environment. So, for example, without going into too much detail, these scenarios would represent a spectrum of futures that range from, say, a scenario that is heavily focused on the exploitation of fossil fuels to another that prioritizes the sustainable development goals and environmental boundaries, or scenarios that focus on regions or countries maximizing resources for themselves at the cost of the broader sustainable development goals. So there is a spectrum, or there's variations in this space for these scenarios along those axes of how fossil fuel intensive to how sustainable, say, in the future, these stories might look like. These scenarios are represented quantitatively as time series data on things like population, GDP, energy use, and so on. And I'll talk about that in a minute. Through the framework, we can also look at policy decisions relating to, say, trade or climate, or pathways to meet targets. So, for example, those that are stated in the Global Biodiversity Framework, or look at specific scenarios that describe societal behavioral change. So, for example, dietary shift scenarios to move away from, say, a meat focused diet. The economic modeling component is handled by what is known as a CGE. So that is a computable general equilibrium model. This work is led by Tom Compass at the University of Melbourne and Van Ha Pham at the Australian National University in Canberra. Now, CGEs are models that look at the economy as a system of interacting and interdependent components. So, meaning industries, consumers, governments, importers, exporters. And they are usually formulated as a very large set of equations which describe the economic behavior of each of these agents. And so they can predict the response of the economy as a whole to change in policy, to economic shocks, trade, and more recently, looking at measures to reduce greenhouse gas emissions. These methods are extremely complex with many equations and many parameters. And at the moment, the model can cover up to 100 countries and 60 or so commodities. And so the strength of our project lies in this collaboration and in being able to show how these complex and diverse set of inputs translate into impacts for biodiversity. What we get from the CGEs in our case is projected demands for commodities under different policies or scenarios. These are results from a case study where we looked at national level implications of a trade liberalization policy for on impacts of a trade liberalization policy on the bird biodiversity of Vietnam. But really, this is just to show that what we can get out of what sort of outputs we can get out of the economic model. And here we see the change in commodity demands compared to 2015 as the baseline under our scenario. So under a business as usual scenario and the TPP, which is the trade liberalization scenario. So I can talk more about the scenarios and the outputs of this study if anyone's interested, or feel free to get in touch. But bear in mind that our work is more methodological at the moment, while we continue to improve or gain confidence in the outputs from our assessments. The next step in the framework is the land use model. Work on the land use model was started off by PhD student Simon Kavitsa and Natasha Cadenhead. So this part of the work, this part of the modeling framework has three components in it. First, we estimate the total area of land use types or classes. So that means when I say land use types or classes, cropland or urban land, grassland, whatever classes you would want to consider in your model. So we estimate the total area of these land use classes that are required to meet the predicted demands for different commodities, what we got from the CGE model. And I'll talk a little bit more about this in a minute. Then once we have the total area by land use class, we then have a land use suitability model, which is a regression-based model similar to species distribution models, which predicts where a particular land use is likely to occur in a landscape given predictor variables. So variables like soil and climate, or proximity to roads or cities, etc., and things like that. So this bit gives us the suitability of a grid cell within that landscape, or pixel, for the different land use classes. So saying whether this particular location is more suitable for urban or agricultural use, for example. The third step captures the spatial interactions and competition between the land use classes to determine how land use is distributed across the study area. So for the first step in the land use modeling, first the commodities So how this is done is the commodities from the CGE are linked to specific land use classes. And then we assume that an increase or decrease in demand for a commodity is linked to increase or decrease in the surface area of the land use class that is required to produce that commodity. So there is a simplifying assumption of a linear relationship in area, or using a multiplier based on the proportional change in demand for commodities between now and in the future. What we get from this step is the area for each land use class required as per our scenarios. Now, it's important to note a few characteristics of this approach. So change in cropland. So, for example, the change in cropland is demand driven. So, what that means is that the total area of this land use type of cropland is estimated first, and then we figure out how it is allocated in the landscape. But conversely, for natural habitats and forests, demand cannot always be determined in a top down sort of approach, except, say, when we're considering managed or harvested forests, or when we are looking at protected area policy, for example. But in most other cases, for natural forests, a bottom up approach is used. So in this case, the total area is estimated after the area requirements for all the other land use classes that are linked to certain commodities has been satisfied. So what that means is that the forest land use category often acts as a source. We can, of course, put some constraints on this by fixing protected areas, for example, such that they cannot change into any other land use class. In the second step, which was to assess the suitability of the grid cells in the landscape, as I said, this is a regression-based model where we use a number of different, we can use a number of different variables to model the suitability. We've been using climate variables, topographic variables, soil or human-related things like distance to cities and distance to roads or protected areas, for example. So coming to the third step now, what we have so far is the total area required per land use class and the suitability of the pixels within the landscape for different classes. Then we come to the allocation step. Now, the initial ideas for this were based in the clues model. So what happens here is that allocation is allocation of the different pixels to whether or not it's going to be cropland or urban land or grassland is determined by establishing some rules on how land use classes transition from one to the other. So this is determined or defined according to elasticity matrices like these that indicate the time and the plausibility of different land use transitions given the current state. So what you see here, for example, that forests are not allowed to transition into shrubland and only allowed to change to cropland if the transition is happening outside of a designated protected area. And for shrubland to change into forest, we can define a time lag to allow for the time for succession to occur if the land is left undisturbed. So what we get at the end of these three steps of the land use modeling component is a predicted land use map under the scenario policy being assessed. So for our Vietnam case study, for example, that was looking at the trade liberalization scenario and a business as usual scenario. We got maps for these two scenarios. And now these are the same maps, but you can see where the changes are actually occurring. Blue represents no change, pink represents change. And the results in this case pointed to changes primarily in grassland and shrubland, So mostly here and here, giving insights about where those future conflicts for land use and biodiversity may be, or what types of bird species might be impacted. And then finally, we come to the biodiversity models. So again, these are regression-based models. Many of you will be familiar with these, as well as the Dismo package for Maxent models, or the PPM Lasso package for point process models. We have developed the workflow to be able to use both of these and to run these for many thousands of species in parallel. Here we can, of course, use any type of biodiversity model, but we are interested in individual species responses, and so we're building individual STMs. This is also a strength of the project because of the exceptional expertise that is available in STMs within the quantitative and applied ecology group at the University of Melbourne. Just briefly about the data that we use. Everything is publicly available, all the data except the trade data, because economists. We are working at 1 kilometer resolution. The socio-economic data underlying the SSPs is available from EASA, and this covers 205 countries and regions, and up to 21, goes up to 2100. So these are projections for things like population, energy use, GDP under the different scenarios. GTAP, this is the trade database, and it's the largest input-output table that provides data on trade flows, production, and consumption for over 140 countries and somewhere around 60 commodities. And I think they have increased these with the latest release of their data, which is version 9. And this data forms the basis of the economic models. The environmental and spatial data sets come from sources like FAO, NASA, and other publicly available remotely sensed products. And we use this within the land use and the species distribution model. So variables like soil, land cover, climate, and so on. And finally, the biodiversity data, which is mainly species occurrence records, so presence only records, from GBIF, or the Atlas of Living Australia, and range maps from the IUCN. So what do we have so far? We have started to apply this framework to a number of interesting questions. Simon, who has recently submitted his PhD, has used this framework to look at direct and indirect impacts of climate change on biodiversity. So he included climate variables either directly in the STMs or through the economic, land use, and biodiversity route. So in this work, he compares predictions for different scenarios for Vietnam and Australia, again, looking at the bird biodiversity, so over 700 species. This work has really highlighted the importance of improving our land use models, as well as thinking very carefully about this link between the economic and the land use models. And this has been the focus of the work and collaborations lately over the past half a year or so. You can read more about this work in his paper, and I've provided the links to some of these studies that I will be referring to in my talk to Fernanda, who will pop them in the chat or the email, or however she deems is most efficient. Following on from that work, Simon has also been developing a much more improved land use change model. So this work was informed from that previous study. And so compared to CLUES, which was our starting point for the development of the land use model, his model offers a much more sophisticated way of firstly modeling land use suitability across the landscape. And he has worked on an allocation algorithm that considers fractional as opposed to categorical data per grid cell. So what that means is that for each grid cell, we now have data on what fraction of the grid cell is covered by the different land use classes that we care about. Now, this is a significant innovation for a land use model in its own right, but also for our analysis, because now we gain much greater detail in the land use data at the 1 kilometer resolution. And this is much more useful for understanding the impacts on biodiversity. So this just shows how Simens' model compares to other models in this space, in that we can work with any resolution. We work with a continuous land use response variable. The whole thing is coded up in R and is free to use. He has the model code available in his GitHub and is in the process of publishing this work. So if you are interested in his work, please do get in touch with Simon. Matthew Cantor, who is another PhD student with the group, has been focusing on the economic modeling component of this framework. One of the main challenges of this project was getting our heads around the incredibly complex and hard to understand CGE models, their terminology and their code. So one of the first things Matthew did was, and he's published this paper from it, is that he provides an in-depth review of CGEs, especially from the perspective of environmental or ecological applications. So he gives an overview of where these models have been applied. So for example, for economic applications, so by theme, so by economic applications, which was the bulk of the studies that were considered in the review, in the energy sector, or in the AFOLU, which consists of studies focusing on agriculture, forestry, and other land use. He also looked at what kinds of models have been used, as there are lots of different kinds of equilibrium models, whether they were applied at the national or the regional scale, or used for global analyses. And also, he also looked at what sectors are considered in these studies and how can we disaggregate these sectors into those that will make sense for biodiversity assessments. Now, this work gives us information on where some of the best data might be available as we start to bring greater detail into the CGEs. And with the work that Matthew's doing, we are also thinking about how to better integrate the SSP data. So data for data that aligns with the SSP trajectories. So basically data on population, energy use, and all these things that are available, how we can better data into the CGE models to represent these scenarios. And we're aiming for an open source R implementation of the CGE model, which is sometime in the making yet. And this is just to show what a horrendous exercise this was. The figure you can actually not see is it basically details about every study that was considered, what model it used, how many regions and sectors and time horizon was considered in these studies. So it's a map of sorts to find the relevant study. If anyone is interested in CGEs, I would strongly encourage you to start here, because it is a wealth of knowledge. And in fact, if you do, please do get in touch and give us feedback as to how how to make such topics, which even we are coming to terms with, trying to understand, all of us being biodiversity and environmental scientists, how to make such topics and studies suitable for us environmental scientists. As I mentioned before, when talking through the framework, we have also looked at the impact of trade agreements on biodiversity. So what we did here was consider that trade liberalization scenario along with an extreme climate change scenario, so an RCP 8.5. And we could focus in on the impacts on individual species and their loss of habitat, as well as stacked species distribution for many birds. So, and we can see that, so in this figure, that depending on the attributes of the species, one scenario might be better than the other. And this may not be consistent across species. So it is very important, therefore, to be able to make these assessment, yes, for a lot of species, so that we can make broader assessments about whether we are going towards or away from goals, and or whether we are achieving the outcomes of policies. But also, it is as important to look at individual species if we want to inform meaningful policy for meaningful policy decisions for species protection. Um, and similarly, we can also predict individual species distributions under realizations of the socioeconomic scenarios through the modeling framework. And we have done a preliminary analysis again for bird biodiversity in Australia. I have provided and the links for all of these as well. So where are we at now? Well, I don't have pretty global maps to show you yet. There is still some work to be done to get there. We also need to fine tune some developments in the individual models. So, for example, things like in better linking the CGE with the land use model, in putting thought into what land use classes we want to use. At the moment, we're using 9 land use classes. Thinking about how to integrate the SSPs, the socio-economic shared socioeconomic pathways, so those scenarios into the CGE, basically how to bring that data into the CGE so that we can represent these scenarios better. We want to have put some thought and conversations about what kind of metrics we want to use for the from these assessments, and as well as resolve some of the computational challenges in scaling up the analyses. But the extremely modular nature of the project, meaning that there were many people working on the different aspects, has meant that a lot of the different bits of the framework have been developed in parallel. So we now have all the data processed and ready to be used in the models. So global data processed and ready to be used in the model. The entire GBIF database, which has been downloaded, cleaned, and set up as a database on our internal servers. Similarly, we have workflows for cleaning and filtering any other kind of biodiversity data, so be it Atlas of Living Australia or IUCN range maps. We have outputs from the economic models, or a start in that direction. So for a combination of different scenarios under climate change, the SSPs and trade agreements, there is a lot to be done there. There is, things we have to figure out, but we have something to work with to start these kinds of assessments with. We are now working on the model evaluation for the land use model, and we are also finalizing the upscaling of this model for global predictions, because up till now it has only been applied to regional scales for testing. And finally, save for a few improvements in the biodiversity models, such as building in proper error checking, automating the workflows to pull data from the databases, parallelization, or including things like sampling bias and some considerations like these. We have the workflows ready to go for the species distribution models as well. So watch this space, and we hope to have many interesting outputs to show you. Outputs that tell us where across the globe, eventually, this is what we want to get to. Outputs that can tell us where across the globe will there be the greatest conflicts for economic, social, and environmental opportunities in the future. Where are the biggest conflicts for land for development, or urban expansion, or agriculture, versus land that is needed to conserve biodiversity, say to meet the target set in the global biodiversity framework, and to provide insights into where might we be able to protect biodiversity and where will we not be able to protect it. So all of these pretty massive questions that do need a lot of collaborations and sustained collaborations. And no one study will be able to address it, but by building this kind of a pipeline, which is open source, which can be, which is completely coded up in R, so it is reproducible. We hope to be able to build this capability, or take it to a level where we can make these sorts of assessments and start to address these sorts of questions. With that, I come to the end of my talk, and I would like to thank you for listening, for your time. I'm happy to take comments or questions, and I'd also like to point before I stop that we do currently have a PhD opportunity with our group to work on some of these challenges or questions that I've talked about today. So please do get in touch if you are interested. Thank you. Oh.
Thank you so much, Payal, for your talk. Very interesting material and a lot of things for us to discuss and think about. We have a few questions, so we can start. Let's see. So Karin said, brilliant stuff. I wonder, though, to what extent the method currently relies on the often not very accurate IUCN range maps. Might that compromise results in practice? Are there alternatives?
Thanks, Karen. That is really good point. And I guess even though you mention IUCN range maps, there will be similar problems with GBIF and ALA data. So mainly we are using the point occurrence, presence only, records from GBIF. How we use the IUCN range maps is more of to find a solution to the size of the analysis, so to restrict the computation. So how we're using them is when we're building the species distribution models, we, instead of say predicting to the entire globe where a species might occur, we sometimes use the IUCN range maps where they are present to be able to restrict the extent to which the model is predicting. So we don't really use the IUCN range maps as like input data for the biodiversity itself. But then again, I do acknowledge that even if we are using GBIF, it does have a number of problems. That data has a number of problems. Sampling bias is one, for example, and we are considering certain methods for how to deal with sampling bias. So just basically, like you have in Maxent, where you can have a bias layer that can go in either as a covariate or something else to modularize your prediction. We're doing single point process modeling, where we include the bias layer as an offset in the model. So it's very hard to say if I've answered your question, and I can't invite you to say if I have or haven't, but yeah, I hope I have.
Sure, thank you. You also answered the question that I have about how you were planning to deal with the sampling bias on future developments of the model. So we have a second question from Jefferson. He is asking, so he's congratulating you first, and he's asking to what extent predictions of this kind of model have been considering by decision makers.
So thanks, Jefferson. So at the moment, the kind of predictions we want to make at the global scale, for example, or national scale, for the global, for example, we haven't gotten there yet, so they're not being used by decision makers. But for national scale assessments, for example, there's a lot of appetite for these kinds of things. As part of the work that we've been doing, we've been talking with some local, as in Australia-based national NGOs or conservation, what do you call them, like TNC cases. And there is a lot of appetite where they want to use these kinds of analyses to be able to plan their conservation project or plan revegetation projects, because the TNC, I think it is, or one of these conservation organizations is quite interested in getting a bit more insight of where, for example, across Australia, would revegetation make most sense? It would be most cost effective for what they're putting in. So there is appetite. And as for the global scale, all the different groups. So there's groups based in the UK and in Germany that are doing these global assessments, as well as CSIRO, which is based in Australia. All of them are working towards informing the global biodiversity framework, for example. So it is definitely these kinds of outputs are being sought after by these frameworks that are looking at global targets or global policies.
So thanks, Payal. So Karen also mentioned that you did answer the question. So we have another question
Sorry,
from.
I just realized that Karen. I know. Hi, Karen.
So a second question from Jeff. He's also asking, is there increasing interest of decision makers in using forecasts from such models as the environmental crisis aggravates?
So at the moment, I haven't. I speak from having been in Australia now for a while, and what I've seen here, the last environmental, and I think Australia is still of 2019, 2020, and Australia is still coming to grips with that. And most of what we're doing is species distribution models and overhead maps, moving on to these types of analyses. In the most immediate environmental crises, I have not seen yet, but there is, like as we mentioned before, there is appetite for these kinds of analyses because people are recognizing more and more that some of the impacts that we're seeing cannot be described just by climate or just by land use change. So people are recognizing that there are social drivers that are causing some of these impacts. So there is appetite, but there is some work to be done to get it to application.
A lot of challenges that we have to deal with in seeing these results applied. So Larissa is also here, and she's asking you how hard is to integrate knowledge from different areas. For example, as you cited, that the economists who do not make their data on trade free to use or so on.
Yeah. Hi, Larissa. It's good to see you in that little picture. It's so the integration between the land use modeling and the biodiversity has not been challenging. But yes, you're right. When bringing in the economic modeling thinking into my work, into this project has been quite hard. One is also because the terminology is so different that it just takes forever to understand what they're saying, and the models are so big and so complicated. So, and it was one of the reasons why we wanted to do that review, because we wanted to at least start with some type of a level playing field where we understood the terminology, we understood what was happening in the model to be able to use it in these kinds of assessments. But you're right that it is a problem when it comes to data not being free, as well as model code not being free, because model code is also proprietary. So to be able to make it open source, we're going to have to think of some clever solutions as to what what cannot be open source. And so therefore you can also, that they can take away this assessment framework and do their own assessments. So there are some things to think through there. And you're right that it's not straightforward and it's not simple because data or the models are not free and language is hard. But it's interesting still.
Yeah, I think it's a big challenge, but it's something that we cannot deny anymore. That we have to work with people from different areas, so we
True.
cannot keep talking only among ourselves about biodiversity conservation and not apply that
Absolutely.
to the
Absolutely. Yeah.
society, right?
Yeah.
So, Larissa has a second question.
Mhm.
If you think that patterns could be different from for developing countries when you think about the predictions, I think, especially related to the relationship between consumption and land use change.
Yes, definitely. That's a really good point. There most definitely will be different. Um, so in the CGE model, what we have is basically data by the sectors, so which was wheat, rice, whatever, but also by the countries. So we will have country specific information about what is being traded, what is being produced, how much of it is being produced, and that information, what we get out of it is, yes, an aggregated demand for a commodity, for example, and this demand is what we're saying is global demand for commodity, which we then apply to the land use model. But you're absolutely right in that we might, further down the line, when we want to look at these differences, which are actually going to be very, very important to understand the differences in the patterns in developing, or, in Africa versus India versus Australia and so on, that we might have to think of bringing in that detail in the land use model as well. So the the elasticity matrix that we saw as to what land use classes change into, what changes are allowed for land use classes, we might have different elasticity matrices for different countries, or we might even have in the biodiversity models, I'm thinking different variables for depending on what region, which species you're modeling, and what region it belongs to. So you're right that this is a quite an important consideration, which as of now we're not bringing in that detail, but is definitely will definitely be important.
So, following on her question, how do you see this trade off between global prediction and local prediction? Uh, so, you showed us the importance of having global information on trade and the economic model to be able, because this is influencing the local condition and the local conservation and prediction of biodiversity in the future. But how do you see the outputs of the model at a global scale or a country scale or regional scale? How do you see that this can be applied or have or be explored?
Yeah, thanks, Fernanda. That's a good question. I think the usefulness of the outputs from this kind of modeling framework are in having, um, country level or a region level kind of prediction. So the the framework takes into account these big processes that are global, data sets which are global, but the predictions are not, as in we think, we feel that are probably not as interesting if you were to just make them as global predictions. To be able to actually say things like, how can we meet that target of how much percentage of protected area, or these many species. To be able to realize some of those targets, we will need to know where you implement what to be able to get to these targets. So what species, what protected areas, in which countries. So it actually makes much more, like, it is much more informative, of course, if we have this information at a very fine scale at local levels. Is that answering your question? Yes.
Oops,
Okay.
I was muted. Yes, sure. Yeah, I think it's very
Right.
challenging to have it at the global scale and global level, and also local level. And they have different applications, like having
Yeah.
predictions, like more
Yes.
robust predictions at local level can inform better decision making, but it's also important to have a look at the big picture.
True. So at the global
Um,
level, I think we that's where we will be considering what kind of metrics do we use when we aggregate these. So you have predictions for individual species, but when you stack them, so many, if you want to see your bird species across the world or um, any other grouping of species. So thinking about if we wanted to have some kind of global outputs and we wanted to say, this is the richness, for example, in this space, then we will want to think of what metrics make most sense when you stack all these distributions, and what kind of indicators would you use in that case.
Great. So we have another question from Hannah.
Mm-hmm.
She's asking, from the preliminary data, which areas are at risk of the greatest land use conflicts? And is it possible to integrate governance indicators, like flexibility of countries to make change, for example?
So thanks, Hannah. I don't think I will be able to answer the first part of the question because we have not been able to run these analyses at the global scale. We expect certain areas to come up when we do run the analyses. For example, from the Vietnam analyses, that was also specific to the scenario we considered. But in the Vietnam analyses, for example, we saw that um, grasslands would be the most impacted, and so maybe those species would be most impacted. But at the global scale, I would be hesitant to say anything at the moment because it does depend on what scenario. We would anticipate, species will be impacted the most because that's where most of the richness might be lost. But I don't know. I don't. That's what we think. Is it possible to integrate governance indicators? So I think so. We have not thought about this a lot yet, but I think if we were to consider governance indicators, so some of them might come in. So depends on what kind of, if it is related to protected area policy, then we could sort of impose some constraints on the land use model. For example, if it is about governance indicators that have to do with flexibility on what is being grown versus what is being imported or exported. Those kinds of things can be tweaked in the economic model. So you can actually incorporate the different policies or a policy that you want to implement through the economic model. So if there was something like we want to um, a policy that says that basic, well, it can't be a policy, but a scenario that says that we want to reduce meat in our diet. And so let's say hypothetically one way to do it is by taxing meat more. And so that would impact how much meat is being exchanged between countries. So that's not a really good example, but there are those kinds of actions basically can be considered by bringing in that information in the economic model. But I'd be happy to hear anything else you have to say, Hannah, either by email or by chat, as to what kind of governance indicators as well you might be thinking might lead us to new kinds of directions. So yeah, please get in touch.
So I have one question related to people getting in touch. I will
Mm-hmm.
post
Mm-hmm.
Payal's email here in the chat. People can get in touch. But I like to hear your opinion on how people can contribute or even apply or use your model once it's finished or under
Mm-hmm.
development. And how do you see
Mm-hmm.
this type of collaborations and how people can
So
contribute?
that's where it'll get actually exciting. Right now, it's just figuring out a whole lot of things and staring at our computer screens. So we are in the process of making a website for the project. All the work that we are developing, whether it is the workflows for the biodiversity models or the land use model, the economic model, not yet. They are all at currently in its different stages of development, but still they are all available on GitHub. But so at the moment, the best way for I think idea exchange or for collaboration would be to get in touch with us. But eventually, what I think we want is to have the workflow, whether they be as a GitHub repository or probably something a bit more sophisticated for which we will need to find funding, is to be able to offer this, framework, this modeling framework, so people can actually plug in their data sets and try. There will be some a lot of documentation. There will be some effort that will need to go into explaining the economic modeling side of the whole pipeline. But yeah, our hope is that we can provide this as an open source thing, so that things like otherwise things like integrated assessment models, which are beyond anyone's reach because they are so complicated, but we hope we don't want our model to become like that. So yeah, welcome.
I'm really happy to see that you have this concern of having it in a transparent and reproducible way that people can actually apply uh, it. So this is, I think, really
True.
helpful for decision making and being applied at different levels. I
True.
have one last
And
question.
actually it's, sorry, yes,
Sorry,
yes,
go
you
on.
go.
No, go on. It's
No,
a
no,
different subject.
no, you go.
Uh, is there, so my question is there any way of trying to validate the results, considering it's a prediction for the future?
Yeah.
This is quite hard, but to
Hmm.
assess the robustness of the model, or are you thinking of any way of testing that?
Yeah, so so we're thinking of it in right now in terms of the individual modeling components. We will have to think in the end as to how do you summarize these kinds of not insights, but summarize these confidence in the different in the outputs of the different aspects. But we so yeah, so to do it for the entire modeling framework. That's my sister, by the way, who's written in Hindi. So that we'll have to do a bit of thinking there, but we are thinking of these kinds of like model evaluation at the level of each of the different models. So for biodiversity and land use models, which are regression based, we are doing that cross validation, k-fold validation, where you hold some data and you use the rest of the data as your training data set, and you see how well it predicts to the data you held back. So bringing in confidence estimates through those kinds of techniques. And for the economic model, which is really the beast of this whole thing, there we want to do sensitivity analyses, because it's hard to do validation otherwise. But sensitivity analyses where, so CGEs, how they work is they have some variables that are intrinsic or what are called endogenous. So these are parameters that are fixed in the model, and parameters that are not fixed. So the not fixed are things like the input data, for example. Those variables are called exogenous. So to be able to test sensitivity, for example, we'll look at we're probably thinking more in terms of like global sensitivity analysis, where you hold one thing constant and you change a variable between a range, and this variable will be the sorts of things we're interested in. So one of the things we're looking at is parameters that have to do with yield, for example, for the different countries. And so, yeah, vary those and see what the the range of the output, and that will give us some estimate of what, how variable or how robust this model is for that prediction. To do it for everything will be challenging, but at least we can start doing the analysis for that parameters that are that we're interested in.
Perfect. That's very clarifying on how you plan to test the model.
Oh,
Uh, yeah. So I posted Payal's email. Please get in touch if you have more specific interest on the model. And I thank you all for being here with us, and especially Payal for being here at midnight talking across the globe about modeling and predicting biodiversity. So I will end this streaming. Payal, please stay there. Okay. Bye, everyone.
yes, thank you.